Hello everyone, welcome to my channel Pragya's Gurukul. Chemistry is all about chemical reactions and equations. In the previous video, we have discussed about the basics of chemical reactions and equations and how to write a chemical equation. The most important and crucial part is balancing of these chemical equations. In today's video, we are going to learn about the balancing of chemical equations in a very detailed and simplified way. So let's begin. Let me start with a few examples. In this reaction, as you can see, though the number of magnesium atom is equal on both the reactant and the product side, the number of oxygen atom is not equal. On the reactant side, 2 oxygen atoms are present, but on the product side, only 1 oxygen atom is present. Similarly, in the second reaction also, the atoms present are carbon, oxygen and hydrogen, but their numbers are different on both the reactant and the product side. Such type of equations are called unbalanced chemical equations. But remember one thing, chemical equations must be balanced. You know why? Yes, so as to satisfy the law of conservation of mass. According to this law, mass can neither be created nor destroyed during a chemical reaction. It means the total mass of the products must be equal to the total mass of the reactants in a chemical reaction. Again, as we all know, mass depends on the number of atoms, isn't it? So, for balancing a chemical equation, the number of atoms of each element must be the same on either side of the chemical equation. Now, can you tell me the basic criteria for balancing a chemical equation or the basic criteria for a balanced chemical equation? Correct. A balanced chemical equation has the equal number of atoms of different elements on both the reactant and the product sides of the equation. Moving on to the most important part, how to balance chemical equations. The simplest method to balance a chemical equation is by heat and trial method, also called the trial and error method. In this method, trials are made to balance the equation by using the smallest whole number coefficient. Hence, this method is called trial and heat method or heat and trial method. This method involves the following steps. In order to illustrate this method, let us take the combustion reaction between methane and oxygen as an example. Step 1. Write the skeleton equation. It means we need to first write the complete unbalanced equation with the correct formulae of the reactants and products. Remember, the order in which you write the reactants and products is not important. Here I would like to mention that we have already discussed how to write skeleton equation in our previous video. Link is given in the description box. Now, the chemical formula of methane is CH4. It burns with oxygen gas O2 to produce carbon dioxide CO2 and water H2O. So, this will be the skeleton equation of this reaction. The next step for balancing a chemical equation is to determine how many atoms of each element are present on either side of the arrow and to compare the total number of atoms of each element on the reactant and the product side. Keep in mind that a subscript indicates the number of atoms. For example, in O2, 2 is the subscript. 2 represents that there are 2 oxygen atoms on O2. Similarly, in CH4, there are 4 atoms of hydrogen and 1 atom of carbon. When there is no subscript, it means there is 1 atom. Now let's count the atoms. On the reactant side and the product side, in this reaction, as we can see, the number of carbon atoms are equal, which is 1. But the number of oxygen atom on the reactant side is 2, while that in the product side is 3. How? 2 oxygens come from carbon dioxide and 1 from water. So total number of oxygens will be 2 plus 1 equal to 3. Similarly, the number of hydrogen atoms are also not equal. On the reactant side, the number of hydrogen atom is 4, while on the product side, it is 2. Is this equation balanced? Obviously not, right? Because the number of oxygen and hydrogen atoms on each side of the reaction are not the same. Step 3. Add coefficients in front of the chemical formulae to equate the number of atoms on both the reactant and the product sides. The most important thing to keep in mind while balancing equations is that we never change the formula of the compound, that is, the subscript. We can only add the coefficients. Now, what are coefficients? These are whole number multipliers. Generally, for balancing chemical equations, we begin with the largest formula of the skeleton equation. Here, the largest formula is methane. Oxygen and hydrogen are balanced in the last step. You know why? Because they usually appear in multiple reactants and products. So, if you start balancing them first, you will be making extra work for yourself. So, let's start balancing this equation from methane. There is only one carbon on the left hand side and the right hand side. So, no need to balance the number of carbon. Now, the number of hydrogen on the left hand side is 4, but on the right hand side it is 2. So, we can put a coefficient 2 before H2O. And this will equate the number of hydrogen atoms, which is 4. But when you add 2 before H2O, the number of oxygen atoms also become 2 plus 2, 4, isn't it? So, to equate the number of oxygen atoms, we need to put a coefficient 2 before the O2 on the reactant side also. Step number 4. Verify the number of each atom. Here, as we can see, the number of carbon atoms on both the side equal to 1. The number of oxygen atoms on the reactant side will be 2 into 2, 4. But on the product side, it will be 2 from the carbon dioxide and 2 from the water. So, 2 plus 2 is equal to 4. The number of hydrogen atoms on the reactant side is 4. But on the product side, again, it will be 2 into 2, 4. So, this equation is balanced now. Now, listen carefully. If you double all the coefficients of this reaction, you still have a balanced equation, isn't it? However, we need to always write the simplest equation. An equation is not properly balanced if the coefficients are not written in their lowest whole number ratio. So, always make sure that while balancing your chemical equation, the coefficients are reduced to their lowest whole number ratio. Here, as you can see, in the first reaction, the ratio of the coefficients is 1:2, 1:2. But as you double it, the ratio becomes 2:4:2:4, which is not the simplest whole number ratio, isn't it? It can be further reduced into 1:2:1:2. So, the correct balanced equation will be the first one.